Hi, welcome to one of the most widely anticipated and exciting happenings in the structural engineering space, the launch of the new RCDC Fe. RCDC, as you know, primarily looked at all the frame elements, and to complement what RCDC does, we've been working on this exciting new offering called RCDC Fe, which primarily looks at all elements which have been modeled as finite elements. So they would be flat slabs, rafts, combined footing, combined pile caps, and so on. Today, what we're going to do is give you a quick look into what the exciting new RCD CFE looks like. Just an introduction, and as we all know, the actual software is coming up very, very soon to be with you. So, what does RCD CFE look like? Rcdc Fe comes with a completely graphical interface. The aim was, since we're working with basically plain elements, we're working with continuities. So instead of working with a lot of tables and numbers, the essence here is on completely visualizing what is happening on screen, seeing the reinforcement, seeing the contours, appreciating what is required where, and so on. So the front end, as you see, is completely graphical. It's just very dynamic, graphical interface. You can zoom, pan, you can rotate, view the actual 3D view or transparent view if you want, and so on. So all of those features are facilitated by the software. As with all RCDC solutions go, the software comes with a host of settings. As you can see, currently we are dealing with a standard flash lab model. Uh, I could go into define and look at the general settings which talk about the material property. Do I want to do a crack width check, initial thermal cracking check, punching shear check? Where do you want to do? Do you want to provide shear reinforcement? Do you want to do a deflection check and so on and so forth? And also the kind of detailing system the user wants to provide, whether he wants to use a mesh plus extra or some localized and so on. So very flexible as is the norm with the RCDC solutions. Very interactive with the user and ability to fine tune and define the way you want to work. Similarly, of course, you can go in and set the entire detailing environment. So I can just go in and say, see the reinforcement setting and set the minimum maximum diameter, spacing, percentages, and so on and so forth. Uh, since this is a quick sneak peek, we'll just look at the key features. So one of the most important features, and especially in plan elements, is the ability to visualize and draw sections. So defining sections is very, very simple here. I can just go and say, let's say, give me a section along x-axis and go and select a location, one here and one here. I get two sections. I say, okay, I want along y-axis and go and select a couple of locations and I get sections. So it's as simple as doing that. And when the drawing gets generated, these sections will get reflected in the drawings. And once this is done, we go into, let's say, the designing of the flat slab, as the case may be. So I just go in here and say design. So it'll pick up the forces, the load combinations from analysis as a normal scenario with RCDCs. Do the entire design and give you an output in a completely graphical environment in a matter of seconds. So it translates that into a design and detail, including listing of elements which are failing. So as usual, we always would want you to know the exceptions, would see where the where there's a failure condition and what corrective action to take and so on. If I go behind this, you can actually see the entire detailing is laid out in 3D. This is the power of RCDC Fe, the ability to visualize. I can go in anywhere and just, you want to rotate something, zoom in. Each reinforcement is actually laid to scale, to size at its actual location. So the ability to visualize is something that we have worked on a lot in the software. What you'll also see if I go to a plan view here is all the reinforcement organized by colors, and the various colors basically denote the various bar dia combinations. So you have a mesh, as you can see here, which is indicated here in the yellow rebar saying T8 at T10 at 150, and various other colors indicating various other reinforcements. And of course, you can then toggle between different views, whether you want to see all reinforcement in one go, whether you want to see just the top reinforcement or a bottom reinforcement. So all of those toggles exist, so you can actually visualize just what you want to see and not flooded with too much of information. So you can just zoom in and pick your view. So I can just go here and say, okay, let's say instead of saying all, I want to just see a bottom X and a bottom Y. So I can actually just visualize the bottom X and bottom Y. I can zoom in here and actually see what's happening at the bottom. Similarly, if I want to go into a top, and if I just toggle off the top X and top bottom X and bottom Y, I can just see just the top reinforcement. So the ability to visualize uh, per exception whatever you wish to see exists in the software. Beyond just seeing the reinforcement, I think from a perspective of editing reinforcement, from the perspective of performance, we've given a lot of tools where you can actually visualize things like a contour of the required reinforcement. So direction wise, reinforcement layer wise, you can actually see what is the required reinforcement as a contour. So you actually see the spread of the reinforcement, the variation across the entire flat plate you're working with. So you get to know if some area is loaded more heavily and you expect larger reinforcement. Is it actually behaving like that? Are you not getting that side of profile? So again, you can toggle between the directions here, so top X and top Y and bottom X and so on. So you can work around. Similarly, I can also go and see a provided. Now, provided actually tells you that what is the actual reinforcement. So required is obviously the AST required, and when I provide a mesh plus extra, so I tend to provide some fixed reinforcement, so you can actually see the provided reinforcement. This again is something that you can see direction wise here, so you can keep on the black are of course the failed elements, so it will actually indicate that. And another interesting view is something known as a capacity view. Here you're actually seeing what percentage of the required am I providing. So generally you obviously provide more than 100%, but there are cases where, especially when using mesh plus extra and so on, you might tend to provide much more than required. So you actually get that efficiency view in one, one image where you can see across directions again what percentage of required am I providing. So you actually get a beautiful contour indicating where am I providing 100, and somewhere it says that you're providing perhaps 300% of required, might be localized areas because you might not locally go and curtail reinforcement and so on. The fact is, we can visualize and you can of course take necessary corrective action. What you can also do, and what the software does, as always in all the Rcdc software, is it allows the user to group reinforcement. So if I want to, I mean, it has already done a grouping exercise during the design process while it arrives at this stage, and that can be seen very clearly if I go into this beautiful radial option here and say, okay, I want to look at let's say column strips. So when I select that, it will actually give me a group view and indicate what are the column grouping it has already created. So if I go to a group called CG2, 3 and so on, so you can see there are small groups with a few. So this is a larger group. There are a lot of other columns which are grouped in here. And what you can see in this view is the thickness, the reinforcement required and so on. Now if you also have a toggle viewer, if you do not want to see the bar dia combination but actually want to see the actual area of reinforcement required, you can actually visualize that also by toggling here. So multiple options to actually zero in and see whatever you wish to see. What you can also do is come in and click on this window. When I do that, it gives me all the constituents of this group, all the individual elements which constitute that group. So you can actually go and select each of those and see the graphic updates and say this is my selected entity. You can then go in and create a new group of that entity, move to another group and so on. So you can define your own grouping, you can edit reinforcement. So all that flexibility, which is again I guess the cornerstone or what is characteristic of Rcdc, is of course delivered in Fe in itself. And once you've done all of this, of course, the crux, and I think what's most important, what we all like, is the beauty and the speed at which Rcdc always gives us all the various outputs. So I can just go into outputs and let's say, of course, we start with a drawing output. I can click a drawing, I can define where I want a GA, I want a top and a bottom reinforcement plan, I want a section drawing, I can select unit scales and so on. And of course, there's a rebark manager where you can define what is the kind of rebark marking that you want. I can go in and define all of that, and I just say okay, it will go and generate a drawing. So as usual, it's a one-click, very fast drawing generation. Where in a matter of seconds, the whole drawing is generated. So as you can see on the screen currently, the drawing gets generated at the top. You can actually see a layout. So the plan layout is here. I can zoom in here, and there are a lot of tables that define the size and the thickness of various elements and so on. If I zoom extends and do zoom in here, you can see a bottom reinforcement laid out here, and if I pan up, you can see the top reinforcement. Of course, if I go to the first view, you can see the section marks are indicated here, what we defined, and I can go in and say okay, the sections are dropped. Now of course these are currently concrete sections because we define them to be sections. You can actually define whether you want them to be concrete sections or sections filled with reinforcement. That option exists. If I just go out here and I go to define and I go to this manage sections, I have the option to say that do I want a concrete section or a reinforcement section, and if I say I want a reinforcement section, it's going to give me a reinforcement section as well. The other output that it gives you, of course, are calculation reports, as we always do. So I can just go in here and say, okay, give me calculation outputs. I say, detailed design calculation report, all cases report, summary, estimation, and failure diagnostics. If I go and say give me a design calculation report, and I can pick elements by the group or individual elements and just create a report. So as usual, the report is formatted with everything laid out step by step, the whole process, a lot of the coefficients, a lot of the assumptions, everything laid out. So the same level of detail that you're used to in the Rcdc software is something which is presented here as well. Further, if I can just exit this, and if I want to do an estimation, I can just go and say, give me a quick fire estimation. I'll click on this button and say, okay, I'm good. It gives you a detailed estimation. So it's giving me concrete grade wise, steel diameter wise, costing. So there's a summary, there's a diameter wise, so multiple reports. So I can go and see a summary and get a one-page quick summary, or I can get a detailed report which is element wise. So all those options available within Rcdc can support multiple views, and you can get whatever outputs you want at the click of a button. What Rcdc of course also supports is a lot of tables, so you can view by table. So it talks about a bird's eye view of what is happening in the design, including which elements have failed, why have they failed, and so on and so forth. So all that information as usual pans out. So in a nutshell, it's something that carries forward the flavor of Rcdc in a completely new area, makes it very fast, very accurate, uh, very visual, and I think visual is something that we worked on a lot in itself. So this was a classical flat slab with draw panels and middle strips and column strips and so on. There are times, of course, when we work with flat plates where we just model a plate uh, with columns and we might not model strips and so on. So Rcdc can work even in that kind of environment where I can view the reinforcement. It's designed here and we're quickly just viewing the reinforcement all across, and I can see something very interesting. So if I go and go into a required, I actually get a required contour. So it's actually telling you here multiple information. One, the blue mesh indicates that this is the basic mesh that is provided, and this local areas are basically talking about, if I go into a plan view here, that this is the required area of steel. So you can see this is basically required. So the various colors which are filled are the required, and that corresponds to this legend here. And the outline basically talks about what is the current provided. So you can actually simultaneously see both required and provided. And of course, this is the basic first cut design. As a user, you would want to change all of this. So suppose I don't want this kind of an output, I want to merge them and smoothen them. I can just select this and go and say, okay, merge them. So when I do that, it will get merged into one entity. So just take a moment, you'll find that the reinforcement provided across becomes the same. And if I just go in and go into an option called give me a provided reinforcement view, you can see the whole area has got the same reinforcement in itself. So works very fast, allows you can basically just pick all of them and say, okay, merge them. So all the locals will get merged into one. So ensuring that, there's not too much of variation in reinforcement, but the important thing here is the user is in control. So he can actually decide, go touch, feel, move things, decide where he wants to do what. So complete control with the user, very interactive, very simple to work with in itself. So I'm going back to the required view where again, once again, you can see the outlines are the same color, but the inner are different color, indicating that the required is different. So you can visualize and contrast between required and provided. You can also do another thing. Suppose I want to create a new zone, so I can just come and say, okay, merge all this, create a new zone, and I just pick 4 points or any number of points and say, okay, create a zone, accept it, and it creates a new zone. So if I go in here and now go to the provided, you'll find that the entire area gets one zone. So you can regularize, your reinforcement provided and so on. And there are a lot of other tools such as smoothen. So if you do that one click, it will smoothen all the rough cut edges and so on. So a lot of ability to visualize and control everything. So the another cornerstone or the assumption that we work with is that a software can suggest, but what a software suggests might not always be the final output, and the user would want complete control to work around all of that. Similarly, we would obviously be extending this to rafts and so on, so you can actually go and visualize a raft. So this is a classical raft. I've done a design. You can actually see a provided mesh here, so you can see the provided as a mesh, the locally extra reinforcement, and you can actually go and view direction wise what is happening. So this is bottom, this is what is happening in top, and so on and so forth. So same philosophy will extend further to combined footings and combined pile caps and so on. So Rcdc Fe, Fe promises to completely revolutionize the way we work with finite element model objects. It ensures that Rcdc now covers your entire gamut of engineering, not only the frame superstructure, but also the substructure and the flat slabs and so on and so forth. So endeavoring to extend the span of automation from to as close to 100% in itself. And of course, more products and more extensions will follow suit. I would like to end here. Thank you very much.